Hey, this is Mr. Beckstrom, and today I want to take a look at an example from section 2.2. This is the limits, and this is similar to exercise number 7. So here's a graph of some function, and it looks like some weird function, probably a piecewise function, but the idea here is that we want to kind of investigate what it means to be a limit and what it means when we have them and when we don't have them. So we really want to be able to visualize it and apply the definition of a limit. So the idea here is that when we're looking at limits and we're saying was the limit as x approaches some value, right, on the horizontal line here, we're seeing what y value it's approaching. So, for example, if I'm looking at as x approaches 2 from the left-hand side, which we mark with a little minus when we're approaching from the left, I'm looking to see what y value am I approaching. So it looks like I'm approaching like somewhere around like 3.4. If I'm approaching 4 from the right, my x value, my y value looks like it's approaching the y value of 5. And we're just looking to see what y value we are approaching, not necessarily what y value is actually there. So for example, this 3 here, from the left, we're approaching the y value of 3. From the right, we're approaching the y value of 3. And as long as we are approaching the same y value from both sides, then we say that the limit as x approaches that value exists, and it exists at that y value, even if it's not defined at that y value. So we're going to see what that actually means, and we're going to do a bunch of these examples. I kind of ran out of room here, so I put the last two up here. But let's go ahead and just go through these. So the first one says, what is the function when x is 3? Well, I just go to 3, and my y value is, the solid dot shows where it is, so that's 4. All right. The open circle there shows that there's no value there, but it's actually defined at 4. Well, what's the limit of our function when x approaches 3 from the left? So as our x values get closer and closer to 3 from the left-hand side, our y values are getting closer and closer to 3. So that would just be 3. What about when we approach the function from the right-hand side? As our x values get closer and closer to 3 from the right-hand side, our y values are getting closer and closer to 3. Even though it never actually reaches 3, that's where it's getting closer and closer to. So that's 3. Now, since both going from the left and going from the right are the same value, then that means that our limit exists as x approaches 3 at the value of 3. So even though it's defined at 4, the limit exists at 3 because that's where it's approaching from both sides. And as long as it's approaching the same value, then that's where we say the limit exists. Once again, this graph is just trying to show you that it doesn't matter that it's not defined there. It just matters that that's where it's approaching. Let's look at this next one. F of 5. So we go to the x value of 5, we go up, and we see that it's defined at the y value of 3. Well, what about when we approach x from the left? So as we're approaching the x, or the value of 5, from the left, this way, our y values are getting closer and closer and closer to 7, right? What about when we approach 5 from the right? That's what little plus means. Well, look, we're getting closer and closer and closer as we're going from the right. We're getting closer and closer and closer to 2. Now, what happens when we look to see the limit as x approaches 5? Well, notice that from the left and from the right, we get two different values. So, does not exist. Why does it not exist? Because the limit from the left and the limit from the right are two different values. And whenever they're two different values, we say the limit does not exist. All right, f of 4. We'll go to 4. We go up and the y value is there. It's at 5. From 4 from the left, so as we're going from the left to this value of 4, we're getting closer and closer to the y value of 5. As we're going from 4 to the right, we're getting closer and closer to 5. And as we approach 4, the only thing we care about is the limit from the right and the limit from the left, which is the same value, which is at 5. Now, why would they ask us about this one here? Because this is going to lead us into the definition of continuity, of a function being continuous. And we're going to have a definition later that says that if the function is defined at a value and the limit exists at that same value, then it's continuous at that point. And this is it. So I find that these problems often in the beginning are way overthought, that they often get really confusing. We just have to learn the very basics, and the basics are, think of like flying somewhere, right? Your destination is your limit. So wherever you're flying to, doesn't matter if you actually land there. You don't even have to land there, but whatever you're flying to, that's the limit. You might actually, just about to land and turn somewhere else, but the direction that you're going, that's what we define as our limit. All right. If you have any questions, let me know, and I hope you have a great rest of your week. And thanks.